Hello everyone. Welcome to the new session of Introduction to Agrometrology. This is the first part of this session, and here we are going to study about the agrometrology. Okay, so in this session we are going to study about the agrometrology. But before going to agrometrology, means agriculture based metrology, let us first understand the meaning of metrology. Okay, so metrology word means meteor. So this means above the earth's surface. So when we are talking about the metrology, out of this metrology, meteoro, this means that we are talking about the earth's surface. Earth's surface, that includes the atmosphere. Okay, and logy means indicating signs. So with the help of science, we are going to study about the earth's surface, that also include the atmosphere part of the earth. Okay, so branch of science dealing with that of the atmosphere is known as meteorology. So this particular science that deals about the atmosphere, that is called as meteorology. Now meteorology is a very important part of today, that is going to help in the agriculture, that is going to help to sustain our resources even. Okay, so this meteorology is very important. Lower atmosphere extending up to 20 kilometers from the earth's surface, where frequent physical process take place. So if this is our earth, so at the surface of the earth, when you go to the 20-kilometer height, okay, 20-kilometer height, all around the globe, 20-kilometer height, in this area, a frequent physical process takes place. Okay, and that physical process is very important, because it gives, in this physical process, due to this physical process, we get rain, there is a fluctuation of temperature, there is a wind. So all this phenomena occur in this particular area up to 20 kilometer from the surface of the earth. So meteorology is the combination of both physics and geography. So when we are studying about the earth, its surface, its physical features, its atmosphere, okay, that is geography. But we are using a science, to study about the geography. Okay, so this physics and geography both combine, and it gives you a new science that is called as metrology. Okay, so metrology utilizes the principles of physics. Without physics, metrology doesn't exist. So physics is a very important part of the metrology. Okay, and it's study about the behavior of air. So metrology utilizes the principle of physics and helps us to study the behavior of air. It is concerned with the analysis of individual weather elements for a short period over a small area. So there is a lot of confusion between the term weather and climate. So when we are talking about the weather, okay, then that is the physical state of the atmosphere at a given place and time, and that is referred to as a weather. So we are talking about a place at a time, this place at one particular time. Then we are talking about the weather of that place. Right? So it is concerned with the analysis of individual weather elements for a short period over a smaller area. So this particular area is smaller area. At one particular time, we are studying the elements of the weather. Okay, the elements which define the weather of a particular place. Next, the study of weather is called metrology. It is also called as a study of weather. So it is often quoted physics of atmosphere, as we know that geography and physics combine to give a new science that is called as metrology. So physics is a very important to study the atmosphere. So it is often quoted as metrology as physics of atmosphere. Okay, so in the examination it can be asked like this, that physics of atmosphere means metrology, agrometrology, okay, climate. So in this way it can be asked. So the correct answer will be the metrology. Okay, now there is a confusion between the weather and the climate. So here we can understand what is the difference between these two terms. Physical state of the atmosphere at a given place of a time. At a given place and a given time. Long-term regime of atmospheric variables of a given place or a area. So this particular climate is for a longer area or a large area, and this atmospheric variable is recorded for a long time. This is for a long time. That gives you the climate. And weather, it is for one particular area and for a particular time. Smaller area, and we are talking about the atmosphere, state of atmosphere or the physical state of atmosphere at a particular time. Not a long regime of a time. For a short duration of time. That gives you the weather. That gives you the weather. Okay. So, agriculture metrology is the branch of applied metrology. Now, earlier we have studied about the metrology. Now here comes the term agriculture metrology. Agriculture metrology means metrology is now used for the purpose of agriculture. Okay, and this is the applied metrology. This is the applied metrology which deals with the response of crops and animals to the physical environment. So generally we want to have a good yield of our crop. Okay, good yield of a crop. For that we are dependent upon our climate, our weather. Okay, so prior to know about the weather, prior to know about the climate, so we go to the metrology. And when we go to the metrology to have a good yield of our agriculture, okay, good response of a crop, good response for our animals, livestock, okay, so that comes under the agriculture metrology. Okay, so it is the study of physical process of the atmosphere that produces weather in a relation to the agriculture production. So with the help of weather forecast, okay, we can forecast our weather uh, by studying the previous pattern of the weather. Okay, and we can forecast for the certain months forward, that in this particular month the rain, how the rain will be according to the study of the pattern of the weather. So we can forecast the weather, and according to that we can plan our agriculture. We can plan our agriculture, right? So planning of agriculture is based upon what? It is based upon meteorological data. Meteorological data. So this data gives you the rain. This data gives you the wind. Okay. This data give you the sunshine pattern, everything. So according to that, you can plan your agriculture, right? So this is called as agriculture metrology. Okay. So it is the science investigating the metrological. What is agrometrology? It is the science to investigating the meteorological, climatological and hydrological conditions which are significant for the agriculture. So this climatic condition, hydrological condition means water availability. Okay, the climatic condition, how it will be, that we get from the our meteorological department. Meteorological data will be there, and you can get that like what will be the climatic condition of that area, what will be the hydrological condition of that area, and according to that you can plan your agriculture and you can increase your agriculture production. You can increase your agriculture production. So it is the science of investigating the meteorological, climatological and hydrological conditions which are very significant for the agriculture. These data are very significant, very important for the agriculture. So owing to their interactions with the object and the process of agriculture production. So by getting these data, you can have a good agriculture production. You can increase the yield of production. So how important these meteorological data now you can understand. So this is about the agrometrology, because the meteorological data is used for the agriculture purpose to increase the agriculture production, to increase the agricultural yield. That is why it is called as agrometrology. Okay. Now, what is the scope of agriculture metrology? What is the scope? Okay. So the study of climatic resource of a given area for the effective production. So this climatic resource, this climatic condition is very, very effective for the production of agriculture. Right? So quantify favorable weather. We can quantify that this particular weather is a very favorable for this particular type of crop. So to quantify the favorable weather, normal for the effective farm operations. So you can have a weather data, you can have the climatic data, and according to that you can plan your agriculture and you can have a proper yield of that particular crop. To develop crop animal weather relationship for estimation of animal crops productivity. To study weather crop pest and disease relationship. So we can have a relationship that in this particular weather, in this particular climatic condition, these type of pests, XYZ pests, are very common. Based on our previous study also, we get previous study that in this particular weather condition, these pests XYZ are very common. So you will be aware with that and you can have a planning to get rid of these pests. Okay, you will be ready that if the pest will come and harm to your crop, then what you will do? You will apply the pesticide. You will use some chemicals or organic pesticides even to get rid of those particular pests. So knowing these climatic conditions, knowing this climatic data from the meteorological department, you will be aware with all these things. Scope of agriculture metrology: to modify microclimatic for increasing the agriculture productivity. You can alter or modify the microclimate of a particular area. We can modify a microclimate. microclimate, okay, by providing your hydrological, uh, like water availability, okay, and the changing the soil, okay. So like this, you can modify the microclimate of a or smaller area, okay, and increase your agriculture productivity. Delineate agroecological zones for the effective use of resources and fast transfer of technology. So we can know that this particular zone is very good for this particular crop, and this particular zone is not good, or yield is less in this area. So we can plan accordingly and have these area for X crop, and this area is not good for X crop, then we can plan some other type of crop according to the soil and the water availability here. Suppose it is good for a Y crop. So we can delineate the agroecological zones. We can delineate this agroecological zones and efficiently use the resources. Efficiently use the resources, and we can have use of our technology and increase our agriculture yield. Okay, so to prepare crop weather diagram and crop weather calendar. So crop weather calendar is drawn to know that in which weather what type of crop growing is suitable in this particular weather. Okay, so these diagrams and these calendars are very important, and they can be timely operated by the farmers to know that in this particular weather what type of crops can be grown. Okay, so to develop the crop animal growth simulation model for the prediction of the productivity in advance, and also obtain the potential yield in the different agroecological zones. So not only that, they will know that in this particular weather we can grow certain types of crop, okay, not one or two type of crops, but we can grow these certain type of crops, and these particular crops are they provide you a great yield, so that uplift the economic condition of the farmers. So these type of planning, these type of things, including or practicing in the agriculture, which is totally based on the metrology, that is totally based on the metrology, is the agriculture metrology, is the agriculture metrology. Okay, so weather and climate, again, it is very important part of this agrometrology. Weather, the state of atmosphere at a given time and place. We are talking at one place and a one particular time. One particular time. Small place. This is a place, right? With respect to the variables such as temperature. So what are the variables? Variables. So temperature, we will know about the temperature, we will know about the wind velocity, okay, we will know about the pressure, we will know about the moisture laden in the air, okay. So these variables, when noted down in a small place in one particular time, it defines the weather of that particular place. It describes the atmospheric condition at a specific place at a specific point of time. So weather, when we are studying the weather, we are studying at for a small place and for short duration of time at a one particular time. So weather generally refers to day temperature. Now temperature fluctuate. The wind velocity fluctuate from morning to evening. Okay. So precipitation activities refers to day-to-day temperature and precipitation activity. So you can know that the precipitation activity according to the day-to-day temperature, wind velocity, pressure, and the moisture availability. So these variables are very, very important to know about the weather of one particular place at a particular time. Now, climate. Now, the climate originates from the ancient Greek word klima, meaning inclination. Very important. Inclination. It is commonly defined as the weather averaged over a long and for a larger area. So we have a larger area, and we know the weather for say 3 months. We know this is for first month means 30 days, second month for 30 days, and third month next 30 days, total 19-day wise variable data. Okay, so that, and we will take about the average of this. So that average condition expected at a specific place at a given time, and that for a larger area. So that will be climate. That will be climate. Okay, so regions climate is generated by the climate system, which has a 5 component. Now the climate system is based on the 5 system, that is atmosphere, hydrosphere, cryosphere, land surface, and biosphere. So atmosphere. So we are having earth, and around the earth we are having a air around us. So that is the atmosphere. Atmosphere. Hydrosphere. So on the earth surface we are having sea, we are having ocean, we are having lakes, we are having rivers. That comes under the hydrosphere. Cryosphere. So we are having water in the form of ice. Okay, so icebergs are there, we are having glaciers. Okay, so all these comes under the cryosphere. Land surface, and also the biosphere. So these all 5 components, okay, generate a climate system, right? Weather variables elements. There are several variables elements that make up the weather and climate of a place. The major of these elements are the temperature, pressure, wind, humidity, and rain. So these are very, very important elements, okay, that are the, we can say, the variables or the elements of the weather. So if you are studying about the weather, then you must know the temperature of a place at a particular time, pressure, air pressure, wind, humidity, and also the rain in the form of precipitation. Analysis of these elements can provide the basis of forecasting weather. So you can forecast that what will be the weather of today, what will be the weather of tomorrow, on the basis of these 5 components. So in the our mobile today we are having a weather app that gives you that in the evening there will be a rain, there will be a thunderstorm. So how they get that forecast? Because they are having these 5 elements, they are continuously studying, continuously capturing, and according to that they are able to forecast the weather and defining its climate. And when you have this weather condition for noting down weather for a longer time, say 3 months, for a larger area, then you can have a climate. You can have a data to determine a climate, right? So these same elements make also the basis of climatology study, of course within a longer time scale rather than it is does in metrology. So these weather condition, knowing this weather condition, okay, it also helps you to study about the climate for a larger scale of time as well as the place. Temperature is a very important factor for determining the weather because it influences or control other elements of weather such as precipitation. So temperature is very important. Temperature fluctuation, okay, so precipitation is because of the temperature. Humidity is also because of the temperature, okay, clouds and atmospheric pressure. So all these comes when you study about the temperature, okay. So when you study about the temperature, you are going to study about the precipitation. Because of the temperature only there is a precipitation, because of the temperature only there is a humidity, cloud formation and atmospheric pressure change. Humidity is the amount of water vapor present in the atmosphere. Precipitation is the product of rapid condensation process. So what happened when there is a heat? When there is a heat, so air and the water vapor on the surface of the earth rises up. Okay, it rises up, and in the upper atmosphere, these water vapor get condensed. They come closer and form the droplets of water. So because of this temperature only, increase of temperature only, there is a process of evaporation and transpiration from the plants, right? So because of the temperature, there is a formation of clouds, right? So temperature is a very important elements of the weather. So precipitation is the product of the rapid condensation process. If this process is slow, it only causes cloudy skies. It may include snow. Now, precipitation not only includes rain, but it also, when we are talking about precipitation, then we are talking about rain, we are talking about snowfall, we are talking about hail, sleet, drizzle, fog, mist, and of course, rain. So this is precipitation form. Precipitation form. These are the different forms of the precipitation. Atmospheric pressure or a air pressure is the weight of air resting on the earth surface. Okay, so when the air is there on earth surface, it apply a pressure. It apply a pressure. And when there is a less air, so the pressure will be less. So atmospheric pressure or a air pressure is the weight of the air resting on the earth surface. Pressure is shown on a weather map, often with lines called isobars. So we are having a weather map that gives you the pressure data, and that is called as isobars. That is called as isobars. Wind is the movement of air mass. When air mass moves away, then that is called as wind, especially on the earth surface. Earth atmosphere. The atmosphere is the thick gaseous envelope which surrounds the earth from all sides, and it is attached to the earth's surface by the gravitational force. So it is a thick gaseous envelope around the earth's surface. It's almost around the earth's surface and form a thick gaseous envelope. So gases like nitrogen, oxygen together makes up about 99% of the volume of the dry atmosphere. These two gases are the major component of the air that constitute 99% of the volume of air. The remaining 1% is composed of a number of different gases that include ozone, carbon dioxide, nitrous oxides, and methane are the most important, that is supports the life on the earth. Ozone is concentrated in a layer that extends from 15 to 55 kilometer above the earth's surface. Now this is a very important. Ozone is very important to us, but it should be at the higher in the atmosphere, near the stratosphere, because it provides the shielding from the ultraviolet rays. So there, that is very important. But this ozone, when present in the atmosphere, it is now poisonous to us. Poisonous to us. So ozone is a harmful gas, or you can say a pollutant, when present in the atmosphere. But when they are present at higher altitude and act as an shield from the ultraviolet rays, then it protect, and that is good. You can say that ozone is very important to us at that level, but not in the atmosphere. Ozone is important to the life because it absorbs harmful ultraviolet radiation from the sun. Okay, so average composition of the atmosphere up to the altitude of 25. So here we are having a percentage of the gases that are present in the atmosphere. So nitrogen 78%, oxygen, that is 20.9, that is approximately 21%, argon, that is around 1%, okay, 0.93, carbon dioxide just 0.036%, and neon 0.0018%. So this is very important to know about the percentage of different gases present in the atmosphere. Water vapor. Water vapor content in the atmosphere ranges from 0 to 5% by volume. Vapor depends upon the temperature, therefore decrease from the equator to poleward in response to the decreasing temperatures towards the pole. So vapor is, again, it depends upon the temperature. So at the equator, the vapor will be more, because more heat comes directly to the surface of the earth. But when we move towards the poleward, the sun rays is slanting. Okay, so heat is lost. Only light reaches to the pole, and there the temperature is less. So less vapor will be there. The content of vapor decreases upward. More than 90% of the total atmospheric vapor is found up to the height of 5 km. It helps in heating the Earth's surface and lower portion of the atmosphere because it absorbs terrestrial radiation. Particulate matter. The solid particles present in the atmosphere that include the dust particles, salt particles, pollen grains, smoke, and volcanic ashes. So all these constitutes the particulate matter of the atmosphere. So they are kept in suspension in the atmosphere. Sky appears blue in color due to the selective scattering of the solar radiation by the dust particles. So the dust particles scatter the light, okay, and that gives you the blue color, and that's why the sky appears blue in color. The salt particles become hygroscopic nuclei, and this help in the formation of water drops, cloud, and various forms of the condensation and precipitation. So this is very important. Salt particles helps in the forms of condensation and precipitation. Okay, so this is all about for this session. We will meet with some more interesting topic related to the agrometrology. Okay, thank you very much.